Dr. T.V. Geeta, Professor, Department of Computer Science, College of Engineering, Guindy, Anna University. Her special interest, Artificial Intelligence and Natural Language. She has published more than 143 articles in national and international journals. She has guided around 7 PhD students. She has got Young Scientist Award from Government of Tamil Nadu in the year 2000, Chief Minister's Special Mention Award in the year 2002, and Woman of Excellence by Rotary Club in the year 2003.
Welcome to the UGC lecture series. In this lecture, we will be talking about certain issues associated with database security and also database authorization. So, the objectives of this lecture are to understand the types of security, to understand the role of DBA in database security, to explain the different types of discretionary privileges, to discuss how to specify, revoke and allow propagation of privileges, to compare discretionary access control and mandatory access control, and to understand a little bit about other security issues like encryption. So, let us start with database security and authorization. Before we go into that, we have to discuss what are the different issues associated with database security. So, there are different types of security. One is legal and ethical issues, that is no one should see our data, policy issues, system related issues, and also one important aspect of database is the need to identify multiple security levels. Now, if you look at if you have used the bank and you have looked closely into its operations, you will see that there are certain operations on the database that only the manager is allowed to do, certain operations which only the accountant is allowed to do, and only certain operations that other personnel and clerks are allowed to do, officers or clerks are allowed to do. So, this is what we mean by multiple levels of security. So, why do we talk about security in databases? The threats to databases include loss of integrity, loss of availability and loss of confidentiality. To protect database against these type of threats, four kinds of countermeasures can be implemented. One is access control, one is interference control, one is flow control, and the other is encryption. So, we are going to look at some of these countermeasures in this lecture. So, a database management system typically includes a database security and authorization subsystem that is responsible for ensuring security to portions of the database against unauthorized access. So, basically what we are trying to, the data security and authorization system of a database is responsible for ensuring that only certain portions of the database are accessible to certain people, that is database certain portions of especially the secured portions of the database should not be accessible to unauthorized users. So, two types of database security mechanisms are available. The first one is called discretionary security measures mechanisms, and the second is called mandatory security mechanisms. So, the security mechanisms of database management system has to do the following: must include provision for restricting access to the database as a whole. So, the complete database is not accessible to everyone, only certain people with certain privileges like passwords or whatever. There are other measures also which we will see later are able to access the complete database. This function is called access control, and it is handled by creating user accounts and passwords to control the login process to the database management system. So, normal like how you control the access to a system, a computer itself, the same way you access to the database is controlled by providing the usual mechanism of user accounts and passwords. Now, the security problem associated with the database is that of controlling the access to a statistical database which is used to provide some information or summaries of values based on various criteria. The countermeasures to statistical database security problem is called as interference control mechanism. So, you are only allowing or controlling the access to the statistical part of a database. Final security issue is data encryption, which is used to protect sensitive data, like for example, credit card numbers that is being transmitted via some type of communication network, but the credit card is available in the database management system. It is responsible to ensure the security of that sensitive data by doing some encryption. So, the data is encoded using some coding algorithm. An unauthorized user who accesses this encoded data will have difficulty to decipher it or look at it, but authorized users are given the decoding or decrypting algorithms or the keys associated with this algorithm to decipher the data. So, this is general computer networks. You have studied security, the same is true. Now, the database security, the role of the database administrator is very large in the case of database security. The database administrator DBA is the central authority for managing the database system. The DBA's responsibilities include granting privileges to users who need to use the system, that is given the privilege to use it. Now, even in databases there are three types: I can access the database, I can update the database, or I can delete items, I can insert items. So, these are four action wise security. So, some users are able to only read or access, some users can delete, some users can insert, some users can only modify. So, that we will talk about later. That is the classification of data. Classification of users. So, as I told you before, manager, accountant, officer, clerk. You can have 4 levels of to the same database, that means to the same set of data, you can have different users being able to access different parts of portions of the database. When we talk about portions of the database, it can be certain attributes or it can be certain tuples, that can happen. So, that means it can be a vertical cut or a horizontal cut. So, classifying users and data in accordance with the policy of the organization is also very important. So, DBA has a DBA account, a database administrator account in the DBMS. It is sometimes also called as super user password, which provides powerful capabilities. It has to do this. So, what is the role of the database administrator? The database administrator is responsible for account creation and password, that is the access control, privilege granting, which is discretionary, privilege revocation, taking off the privilege, that is also discretionary. Certain users are given certain privileges, and security level assignment is done by the control of the mandatory authorization. So, the database administrator is responsible for the overall security of the database management system. So, access protection, user accounts and database audits. Whenever a person or group of persons need to access a database, what should we do? So, the individual or group must first apply for a user account. The database administrator will then create a new account number and password for the user. He has a legitimate need to access the database. Then the user must log on to the database by entering the account number and password whenever the database access is needed. This is the basic way in which user accounts is done. Now, in addition, the database administrator must keep track of all operations on the database that are applied by a certain user throughout its login session, and you must also keep an update on or record of the updates. We can modify the system log, which includes an entry for each operation applied to the database that may be required for recovery from transaction failure or system crash, that we have seen already. Now, if any tampering with the database is suspected, a database audit is performed, which consists of reviewing the log to examine all accesses and operation applied to the database during that certain time period. Database log that is used mainly for security purposes is sometimes also called as audit trail, but actually this the system log that is used for recovery as well as the system log that is used for security are almost the same, but then what you do with that log is different, and if that log is used for such purposes, security purposes, it is called as audit trail. Now, let us look at the first part of the discretionary access control, which is based on granting and revoking privileges. So, this is a discretionary access control. So, the typical method of enforcing discretionary access control in a database management system is based on granting and revoking privileges. So, the account level, so we have certain types of privileges. So, the account level, at this level the database administrator specifies the particular privileges that each account holds independently of the relations. So, for the complete account, irrespective of what all are the relations in the database, for the complete account there is a privilege. So, that is the account level. You can also have privileges at the relation or table level. At this level, the DBA can control the privilege to access each individual relation or view in the database. So, this is not for the complete database, this is only for a particular table or relation. So, that level also you can fix the security. Now, the privileges at the account level applied to the capabilities provided to the account itself can include create schema or create table privilege. To create a schema or base relation, this is allowed. Create view, that privilege is allowed. Alter privilege, to apply schema changes such as adding or removing attributes. So, look at this, the complete design, that access is given to this account at the account level. So, we saw before the account level security. So, you can create a new table, you can create a new view, or you can alter the table by adding or deleting certain attributes. You can also drop privilege, you can delete complete relations, you can modify, you can insert, delete or update tuples, and you can have the select to retrieve information. So, this is the highest level. So, you can create a table, create a view, alter the size or the attributes of the table, you can drop a table, you can modify the table by inserting, deleting or updating tuples. You can also do select, that is select some tuples from the database. The second level of privilege applies to the relation level, at the relation level, and whether they are base relations or virtual relations view. The granting and revoking of privileges generally follow an authorization model for discriminatory privileges known as access matrix model, where the rows of a matrix M represent subjects, users, accounts, programs, and the columns represent objects which are relations, records, that is tuples, columns, that is the fields, views, that is got from the table, and certain operations. So, each position, remember it is a matrix where the rows correspond, each row corresponds to a user or the account or the programmer, and the columns correspond to the objects. Now, each position Mij in the matrix represent the type of privileges, for example, read, write or update, that a subject I means subject is either the user or the account of the programs, can give to type subject I holds on object J. Object can be again relations, records or tuples, columns, views and so on. So, to control the granting and revoking of relation privileges, this is as far we saw the previous one, this is for account level. Now, we are talking about, remember we are talking about relation level. So, to control the granting and revoking of these privileges, each relation R in a database is assigned an owner account, which is typically the account that was used when the relation was created in the first place. The owner of a relation is given all privileges on that relation. The owner account holder can pass privileges on to any of the owned relation to other users by granting privileges to their account. So, an account owner can pass privileges that he has for his account to others by granting privilege. The mechanism of use is an important discretionary authorization mechanism in its own right. For example, if you have an owner A of a relation R and he wants another account B to be able to retrieve only some fields of R, then A can create a view V of R that includes only those attributes that he wants B to read and then grant select on B to B. The same applies to limiting B to retrieving only certain, this is only certain attributes. Here you can have certain tuples of R. The view V can be creating by defining the view by means of a query that selects only those tuples from R that A wants to allow B to access. So, you have again two aspects. A view can be created to include only certain attributes, that is projection basically, and you can create a view to allow only certain tuples, which is again a select. In some cases, it is desirable to grant the privilege to a user only temporarily. For example, the owner of a relation may want to grant the select privilege to a user for a specified task and then revoke that privilege once the task is completed. Hence, a mechanism for revoking privileges is required. Whenever owner A of a relation R grants a privilege on R to another account B, privilege can be given to B with or without the grant operation. So, we are going to talk about the next option, which is the grant option. If the grant option is given, this means that B can also grant the privilege on R to any other accounts that he wants. Suppose B is given the grant option by A and then B grants the privilege on R to a third account C also with a grant operation. So, it can be propagated. In this way, the privileges on R can be propagated to other accounts without the knowledge of the owner R. If the owner account A now revokes the privilege granted to B, all the privileges that B had propagated based on that privilege should automatically be revoked from the system. So, let us take an example. Suppose that DBA creates 4 accounts A1, A2, A3 and A4 and wants only A1 to be able to create the base relations, then the DBA must issue the following: create schema in SQL2, create schema example authorization A1. So, he is authorized to create an account A1. User account A1 can create tables under the schema called example. Suppose that A1 creates 2 base relations, employee and department. A1 is then owner of these 2 relations, that is employee and department, and hence all relation privileges on each of them will be he will have. But suppose that A1 wants to grant A2 the privilege to insert and delete tuples in both of these relations, but A1 does not want A2 to be able to propagate these privileges to additional accounts. He wants only this fellow to have grant insert deletion on employee department to A2. So, he is not allowing the grant option. So, we will continue to see an example of this, how the operations can be granted relation wise, attribute wise, tuple wise after the break. So, now let us take a small break. Welcome back after the break. Now, let us take this example, employee with has name, social security number, birth date, address, sex, salary and department number, and let us have department with department number, D name of the department and the SSN of the manager of that department. Now, suppose A1 wants to allow A3 to retrieve information from either of the two tables and also to be able to propagate the select privilege to other accounts. A1 can issue the command grant select on employee department, these are the two relations, to A3 with grant operation. So, select operation alone can be done for both the accounts. Okay. A3 can grant the select privilege on the employee relation to R4 by issuing grant select on employee to grant select on employee to A4. Notice that A4 cannot propagate the select privilege because grant option was not given to A4. So, grant select with grant option was given here, which means A3 now has can propagate it to A4, but A4 is not given the with grant option. So, A4 cannot propagate it further. Suppose that A1 decides to revoke the select privilege on the employee relation from A3, A1 can issue revoke select on employee from A3. Now, the DBA is now automatically revoke the select privilege already given to, we have given the select privilege to A4 this way. Because A3 granted that privilege to A4 and A4 now does not have that privilege. So, suppose A1 wants to give back to A3 a limited capability to select from the employee relation and wants to allow A3 to be able to propagate the privilege. The limitation is to retrieve only the name, birth date and address attributes and only for the tuples with the number equal to 5. A1 will then create the view. So, here is the view creation, create view A3 employee as select name, birth date, address from employee where department number is 5. So, after this view is created, A1 can grant select on the view A3 employee to A3 as follows: grant selection on A3 employee to A3 with grant option. So, that is about mandatory discretionary access control. Now, we will look at mandatory access control for multi-level security. So, mandatory access control for multiple level security, the discretionary access control that we saw up to now were techniques for granting and revoking privileges on relation and has been traditionally been the main security mechanism for most relational database system. This is all or nothing, that is a user either has or does not have a certain privilege. Now, in many applications an additional security policy is needed that classifies data and users based on security classes. This approach is called as mandatory access control, would typically be combined with discretionary access mechanism in most cases. Now, this mandatory access control, you have typical security classes such as top secret TS, secret S, confidential C and unclassified U, where TS is the highest level of security and U is the lowest level of security. So, the top secret has greater security than secret, secret has more security than confidential, confidential has more security than U. The commonly used model for multi-level security is known as Bell-LaPadula model. It classifies each subject like before user account program and also the object, relation, tuple, column, view or attribute, view and operation into one of the security classifications T, S, C or U, clearance classification of a subject S as class S and to the classification of an object as class O. So, the first is it does 4 levels of security and 2 types of classes. 2 restrictions are enforced on data access based on the subject object classifications. A subject S is not allowed to read access to an object O unless class of S is greater than or equal to class of 0. This is known as a simple security property. A subject S is not allowed to write an object O unless class S is less than or equal to class O. This is known as star property. Okay, so, you have 2 types of property, regarding read access and write access. To incorporate multi-level security motions in the relational database model, you consider attribute values and tuples as data objects. Hence, each attribute A is associated with the classification attribute C in the schema, and each attribute value in a tuple is associated with the corresponding security classification. So, in this way, each attribute is associated with the classification. There we could go only up to record, and it is permanent. Not permanent, it could be done either all or nothing. In addition, in some models, a tuple classification attribute TC is added to the relation attributes to provide a classification for each tuple as a whole. Hence, a multi-level relation schema R with n attributes could be represented as A1 C1, A2 C2, A n C n TC, where each CI represents a classification attribute associated with the attribute A. So, which is the classification attribute that you are going to use? The value of the TC attribute in each tuple T, which is the highest of all attributes classification within that T, provides a general classification of the tuple itself, whereas each CI provides a finer security classification for each attribute within the tuple. So, the apparent key of a multi-level relation is a set of attributes that would have formed the primary key in a regular relation. So, other integrity rules also exist called null integrity and inter-instance integrity. Informally ensure that if a tuple at some security level can be filtered from a higher classified level tuple, then it is sufficient to store the higher classified instead of the multi-level relation. So, let us now compare discretionary access control and mandatory access control. So, discretionary access control, the one that we first saw, where we could have access, grant and revoke privileges, are characterized by a high degree of flexibility, which makes them suitable for a large variety of application domains. The main drawback of DAC is that vulnerability to malicious attacks such as Trojan horses embedded in application program. In many practical situations, discretionary policies are preferred because they offer a better trade-off between security and applicability. Mandatory access control, by contrast, ensure a high degree of protection and they prevent illegal flow of information. Drawback are, it is too rigid and they are only applicable in limited environments, it is not looked at in a complete environment scenario. Now, let us look at introduction to statistical database security. Statistical database are used, we spoke about this in the beginning. Statistical database are used to produce statistics on various populations. So, for example, I want to take all the students of the college, of the university, and then try to look at what is confidential. The database, but I can give an overall impression that the average age is this is the subject most loved and so on, instead of but not give the complete information. May contain confidential data on individuals which may be protected from the user access. Users are permitted to retrieve statistical information on the population, such as averages, sums, counts, maximum, minimums and standard deviations, typical statistical parameters. A population is a set of tuples of a relation that is satisfied some selection condition. So, statistically involves applying statistical functions to a population of tuples. For example, we may want to retrieve the number of individuals in a population or the average income of a population. However, the statistical user are not allowed to retrieve individual data such as income of a certain person. Okay, but you can do some averaging of all the people and then give a value. So, statistical database security techniques must prohibit the retrieval of individual data. Okay. This can be achieved by prohibiting queries that retrieve attribute values and by allowing only queries that involve statistical aggregate functions such as count, sum, mean, max, average, standard deviation and so on. Such queries are called as statistical queries. It is DBMS's responsibility to ensure confidentiality information about the individuals while still providing useful statistical summaries of data about those individuals to users. So, provision of privacy protection of users in a statistical database is very important, very important. In some cases, it is possible to infer the values of individual instances from a single sequence of established queries. So, this is particularly true when the conditions result in a population consisting of a small number of tuples. So, let us look at the next topic, which is encryption and public key infrastructure. Already looked at encryption and private key when we public key and all the security algorithms, and we were talking about databases. But encryption is encryption is defined as a meaning of maintaining secure data in an insecure environment. It consists of applying an encryption algorithm to data using some pre-specified encryption key. So, the resulting data has to be decrypted using a decryption key to recover the original data. Now, The data encryption standard called DES, you would have all heard of this. The system is developed by the US government for use by the general public. It has been widely accepted as a cryptographic standard both in the United States and abroad, but DES can provide end-to-end encryption on the channel between the sender and the receiver, end-to-end encryption. DES algorithm is careful and complex composition of two fundamental building blocks of encryption, substitution and permutation. So, the algorithm derives its strength from repeated application of these two techniques for a total number of 16 years. Plain text is encrypted at blocks of 64. After questioning the adequacy of the DES, the National Institute of Standards produced advanced encryption standards called AES. This algorithm has a block size of 128 bits and that takes longer time to crack. So, it is more easier to crack a simple method that we gave before. Now, we are trying to give a block size so that it can be done. So, this is a famous public key encryption algorithm proposed by Diffie and Hellman in 1976 and a new kind of cryptographic system which they call as key encryption. So, public key algorithms are based on mathematical functions rather than operation on bit pattern. So, he is trying to say how DES is different. So, they also allow the use of two separate keys in contrast to conventional encryption which uses only one key. The use of two keys, why do you want to use two keys? Because two keys can have profound consequences in the area of confidentiality, key distribution and authentication. The two key used for public are referred to as public key and private key. The private key is kept as a secret, but it is referred to as a private key rather than a secret key because of convention and to avoid confusion with conventional encryption. Okay. Now, a public key encryption scheme or infrastructure has the following 6 ingredients. One is the plain text, the data that you want to feed it to the algorithm as input, and then you have encryption algorithm. This is the actual algorithm which performs various transformations on the plain text. Then public and private keys, these are pairs of keys that have been selected so that if one is used for encryption, the other will be used for decryption. The execution transformation performed by the encryption algorithm depends on the public or private key that has been provided as input. Then you have the ciphertext. This is the scrambled message produced as output. It depends on the plain text and the key. For a given messages, two different keys may also give two different types of ciphertext or output. Then finally, we come to the decryption algorithm. This algorithm accepts the ciphertext and matching key and produces an original plain text key. So, public key is made for public and private keys known only by the owner. A general purpose public key cryptographic algorithm relies on one key for encryption and a different but related key for decryption. The essential steps are as follows. Each user generates a pair of keys to be used for encryption and decryption. Each user places one of the keys in a public register and other in an accessible file. This is the public key. The companion key is kept private, the other key. If a sender wishes to send a private message to a receiver, sender encrypts the message using the receiver's public key. When the receiver receives the message, he or she decrypts it using her public key. No other recipient can decrypt the message because only the receiver knows his or her private key. The RSA algorithm, a slight improvement of this is the RSA algorithm. One of the first public key schemes was introduced in 1978 by these people. The RSA algorithm incorporates results from number theory and combined with the effect of determining the prime factors of a target. The RSA algorithm also incorporates modular arithmetic, which is MODEN. So, then we have a digital signature. It is an example of using encryption techniques to provide authentication of services in an e-commerce scenario. Is a means of associating a modern unique to an individual's body or text. So, a digital signature consists of a string of symbols basically, and you do some operations on it to get the correct one. So, we have talked about database security and the role of DBA. We discussed the different types of discretionary privileges, explain how they specify, revoke and allow propagation, compared the two discretionary and mandatory, and then we looked at encryption. And here I would like you to differentiate between the types of security, explains the takes taken by DBA to ensure security, discuss with an example how to specify, revoke and allow propagation of privileges using 5 accounts, discuss the different types of encryption. Thank you.